So, in this video, let's solve the third question of biweekly context 136. I'm pretty sure that this might be not that easy. So, but let me try to explain this easily for you. Let's deep dive into the description, and it's similar to the second question of the context, but here all the rows and columns should be polynomial. But in the second question, either rows or columns can be polynomial, and we need to find the minimum count. In this case also we need to find the minimum count, but all rows along with columns should be polynomial. And there's also other case that all the ones or sum of all the ones that's present in the grid should be divisible by 4. So number of ones present would should be either 0, 4, 8, 12 and so on. Great, that's fine. Let's analyze this and let's try to first build a intuition of finding all rows and columns equal, and let's add this condition of divisibility by 4 later. So if I considered an 2 by 3 matrix, sorry, first let's start with a square matrix which would be 4 on 4 matrix. So if I consider a 4 on 4 matrix, then my elements would be just a second. If I consider a 4 on 4 matrix, then I'll just open my sheets over here to just explain how it would work. So if I consider a 4 on 4 grid, then it would be this, right? So this would be this. And for this, if I consider the first element to be x, then given in the question that we need to make all rows and columns to be polynomial. So if this is an x, then this needs to be read same from the backward, either in row or in column, because we need to make this grid palindromic in both row wise and column wise. So if this is x, then this also should be x, and if this is x, this also should be x because rows also needs to be polynomial, and this is x because columns also needs to be polynomial, and this is x because this is x, so this also should be x, then only this will become polynomial. And if this is y, this also should be y, then only this will become polynomial. And if this is y, this also should be y. If this is y, this also should be y. In the same way, if this is z, this also needs to be z. And if this is z, then this also needs to be z. If this is z, this also needs to be z. A. Got it. No, it's not that difficult, or it's very easy. So if we consider the first number to be x, then in the same row, the last element also should be x, and within the same column, the last row element also should be x, because this needs to be read same in column wise also. So if I started reading from the first row from left to right, then I'll be getting a what string? X, Z, Z, J. And this should be same X, Z, Z, X. If, this should be same if I read from right to left also. If I read from right to left, then also it should be X, Z, Z, X only. So this is in case of even matrix or square matrix. Square matrix in the sense the number of rows are equal to number of columns. But now let's consider a condition where we'll consider a matrix which is having 5 rows and 7 columns. So that would be 5 rows, 7 columns. So that would be this. So this is having 1, 2, 3, 4, 5 rows, 1, 2, 3, 4, 5, 6, 7 columns. So let me just reduce the cell size of it to make everything clearly understandable now. So if both, if it's even, then it's fairly simple. If either one of them, either number of rows or number of columns, or both of them are odd, then this approach works fine. Let me explain you what approach is. In the similar to the early condition case, if this is x, this also should be x, this also should be x, this also should be x. If this is y, this also should be y, this also should be y, this also, sorry, this is not, this also should be y. And let's leave this row for timely purpose, and I'll consider this column. I'll call it A. If this is A, this also should be A. If this is A, this also should be A. And if this is A, this also should be A. Followed by this, if this is B, this also should be B. And if this is B, so this also should be B. If this is B, this also should be B. I'll, for timely purpose, in the similar way, I'll not consider this column. And if this is Z, this needs to be, sorry, I won't consider this row. So if this is Z, this also needs to be Z, this also needs to be Z, this also needs to be Z. Oh, not this. This also needs to be Z. And it's kind of simpler now. And that's, if this is Z, this also should be Z. Sorry, this, I added one column earlier. So if this is D, this also should be D, this also should be D, this also should be D. So I'll just ignore this for now. And to make these operations minimal, so we already knew that if this is my first row, second, third, fourth, first followed by first call, second call, third call, fourth call. So my first row, first element, along with first row, fourth element, along with fourth row, first element, and fourth row, fourth element should be equal. Similarly, first row, second element, first row, third element, and third row, sorry, fourth row, second element, fourth row, third element should be same. So in other way, my first element along with, sorry, ijth element, I will consider it as ijth element along with, if I consider ij, then in the ith row, n minus j minus 1 element should be same. N minus j minus 1th element should be same. And to make the, or to add the condition for column as well, n minus I minus 1th element, sorry, 1th row, jth column element should be equal. And as this is should be equal, then this also should be equal. In the other case, n minus I minus 1 along with n minus I minus j should be also equal, right? And here I'm considering only one because this is a square matrix, but if this is not a square matrix, then this would be m and n. So let's code this first, and I'll explain you the next part afterwards. So I'm not sure if I'll be given a square grid or not, so I'll have m for keeping track of number of rows and n for keeping track of number of columns. I'll call it grid 0 dot size. Now I'll call count zeros, or I'll call it int ans would be equal to 0. And now it would be, so I'm going till m by 2 only. In either case, either if it's even or odd, then I'll be going till m by 2 and n by 2 only. But if it's odd, then there needs to be extra row or column to be considered, or those can be both of them as well. In this case, my eighth element would be, or A in the sense, my first element would be grid of I, J, first row, first element. And in second would be grid of ith row followed by n minus j minus 1th element, right? And third would be grid of m minus I, sorry, m minus I minus 1th rows, and it would be the same jth element. And if I consider fourth element, then it would be m minus I minus 1th element followed by n minus j minus 1. So I'll count zeros count zeros count here would be, I mean, out of these four elements, uh, to, so first, to check this out, like to find the minimum number of operations, these four are to be same, right? So if these four are to be same, and out of these four, already three of them are zeros, then it's better to convert the last one also to zero. And if out of these four, all four are having either two ones and two zeros, then it could be anything like two zeros could be converted to two ones, or two ones could be converted to two zeros. That depends upon our use case. And now, one might ask me that there's also divisible by 4. I told you that can be handled later, but what in this case? In this case, how would that work? So here, all four of these are equal. So either if all four of them are ones, then it would be 4. If all four of them are zeros, then it would be 0. So in our condition, if either it's a square matrix or odd, where we are considering only this part, leaving the odd row and odd column, then if we kept all elements to be zeros or ones, then this divisible by 4. So until now, there's no clash to the rule that's given that it should be divisible by 4. So for zeros count, I'll check if my first element is 0. If my first element is 0, then it would be true, and true will be giving me a value 1. Second is 0, followed by third is 0, followed by fourth is 0 again. And once count, it's simple now. I'll check if my first element is equals to 1 plus second one equal to 1 plus third one equal to 1, and followed by last fourth one is equals to 1. And I already told you my answer will be added the min of this zeros count or ones count. Why min? Because the minimum value only will be changed to the one which is having the maximum value. So till yet, we are okay with everything, but now we could be having odd row and odd column remaining, and this is also a special case of it. So for considering the odd row and odd column of it, what I'll do is simple. So if this is 1 and this is 0, this is 1 and this is 0. For example, I'm just considering an example. I could have two cases. One is if the pair is unsimilar, or in the other case it would be similar. So if my pair is unsimilar, that's one element is 1 and the other element is 0, and if my pair is similar, then 1 1 or 0 0 do exist. So I'll just if my pair is unsimilar, then any we could change them to both zero zeros or one ones. In how many ways? In one way only. But if it's 1 1, then to change it to 0 0, we need two operations. Got it right now. Now, having said that, I'll just go or traverse through the remaining row and remaining column present. So when would I say my my row is remaining or not? If my total number of rows are odd, then I'm not processing the middle row. So if my ampersand 2 is not equal to 0, then I haven't processed that earlier, so I'll process that now. So as I told you that there would be unequal pairs and similar pairs, so I'll call it unsimilar pairs will be equal to 0, and int similar pairs also would be equal to 0 at the very beginning. If and these similar pairs, I'll count them only for 1, because for 0 there's no need of counting. If it's 0 or if every element is 0, then it's automatically divisible by 4. But the condition that will provide us possible error is because if they are ones. Because if a pair is having ones and there are odd number of pairs, then there would be 6 ones. 6 ones would not be divisible by 4, but 6 zeros would be divisible. So ones will give us certain possibility of error. So I'll count odd pairs, sorry, similar pairs, and that's only for ones, not for zeros. So if my ampersand 2 is not equal to 0 in the sense that I'm having odd number of rows, in that case, I'll iterate till my nth column for the particular row, and I'll do check. Here again, nth is not needed, n by 2 is only needed because for checking the palindromic sequence, we only will iterate till the half part of it. I'll increment, I'll check if my grid of m by 2th row, right, m by 2th rows and jth element is not equal to grid of m by 2th row, and column here would be jth column, so it would be n minus j minus 1. If that's not equal, then unsimilar pairs would be incremented by 1 for sure, because we found unsimilar pair, and my answer also will be incremented by 1 because in I need to change either of them to 0 or 1. That depends upon our need, but answer would be incremented by 1. Or else, if those are equal and if my grid of m by 2 zth element is equals to 1, then similar pairs would be incremented by 1. I already told you that we will keep track of only one similar pair, so it will be incremented by 1. This should be same if I'm having odd number of columns as well. Just need to change variable names of it. So if it's n% to equal not equal to 0, then I'll iterate till my middle row I plus plus, and this would be if my ith row column would be n by 2, and this would be m minus I minus 1 followed by n by 2, and similar pairs also would be increased by 1. Answer also will be increased by 1. I'm not sure if I modified that in above condition. If that's the case, then I'm sorry for it. So I'm following at the current place only. So it would be n by 2. Right, and here it would be I and n by 2. Now, fair enough. Having said this, there's one element that's remaining, and that's the middle element. So, according to you, could this be 1? The answer is no. Because if this is 1, there's no corresponding pair element for this, and this would always give us an odd number, and not an even number, even. But if we consider these elements, then if these two are ones and remaining everything is 0, then in that case this would be at least giving us an even number, but here it would always provide us an odd number. So this obviously needs to be 0. This couldn't be 1, because if this is 1, then we couldn't do anything, because if we changed rest everything to 0 as well, then there would be 1 1, or if we changed everything to 1, then also that's an odd place, so there would be some additional number only. So this one should or this one should always be 0. So my answer would be incremented again by 1 if my grid of if m%2 not equal to 0 and n%2 not equal to 0, answer would be incremented by 1 if my grid of m by 2 and n by 2 is equals to 1. Now we had this done. Now suppose, consider this case that there are similar pairs. If similar pairs of ones, right, because similar pairs we are considering only for ones, if those are not equal to 0 or percentage 2 not equal to 0, if percentage 2 is equals to 0, or if similar pairs are from 0 2 4 6 8, if there are 0 similar pairs, it would be 0. If there are two similar pairs, in one similar pair there are two elements, two ones, and in two similar pairs there would be four ones, and in one similar pair there are four pairs, so that would be 8, it would be 12, it would be 16, right? So if there are even number of similar pairs, then it's fine, because in that case it will be always divisible by 4. But if there are odd number of similar pairs, in the sense that similar pairs percent 2 not equal to 0, then we do have two options. That's if unequal pairs or unsimilar pairs is equals to 0. If unsimilar pairs are 0, in that case, we need to add 2 to the answer, because there are no unsimilar pairs that are found till yet. And also I'm having three similar 1 1 pairs. So 3 1 1 1 1 1 1. So in this case, to make it divisible by 4, we need to make two ones as zeros. So my answer would be incremented by 2. And why do we not need if unsimilar pairs are greater than 1? The reason is simple. So if my unsimilar pairs are already greater than 1 and my similar pairs are 3, for example, see, my similar pairs are 3, 1 1 1 1, my similar pairs of ones are three similar pairs, 1 1 and again 1 1. So here there are three similar pairs of ones, and I'm already telling you that there is already one unsimilar pair found, because of which we added 1 to the answer already. So in this case, I already told you if this is 0 1, then any of this element can be changed to any other. But we are already having three pairs. So to add a supporting pair, instead of changing this 1 to 0, I'll change this 0 to 1. So now there would be four similar pairs of ones. So there will be answer would be increased by 1. So if there are unsimilar pairs, I'll just make sure that to get a fruitful answer, in the unsimilar pair, 0 will be converted to 1, and only one pairs, and remaining everything it would be 0 only. But if there are no unsimilar pairs, then obviously there's nothing to do but convert these two ones into zeros. So in this case, I'll just return my answer. I'm not sure what's the error for it. Third spelling is written wrong. I'm sorry for the bad. And now what's the error of it? Great. Just forgot to change the variable name. And again, what's the and yeah, equal to is not added. So there's something missing out here. Let me check that out. For third condition, I should be getting, oh, this should be equivalent to 0. If that is equal to 0, then answer should be increased by 2, right? So I'll just submit this out. Great, we bet 100% fair. I'll also do some more things to make it work faster. I'm just specifying that I do not need to take input or output from any library, so do not tie any libraries from C for input and output. And now you could see it's 291. After adding this, that would be further reduced. For sure, it would be reduced. So it's 254. Thank you.